Hello. I realized that when I prove this, we have to limit ourselves by n is three or more. Okay, because it's easier that way. Okay, so I'm sorry. When n is equal to two, we're gonna prove it separately. Okay, because that'd be easy, right? When n is equal to two, prove that. We'll prove that. Okay. But we have to do it separately because I realized that for generic case, yeah, we have to omit two. We have to start from three. Okay, so I didn't I didn't want that to happen, but I realized that's necessary. Okay, so and I'll tell you why. Okay, so yeah. Okay, let's get back. All right, it's not an easy proof. I'm telling you. Mm. So when n is 3 or more, okay, n minus 1 is 2 or more, right? So that's the key. That is the key. Because in this step, okay, so uh, you have row on the right hand side n minus 1, right? When n is 3 or more, n minus 1 is 2 or more, which is bigger than 1. Okay, so we can express 1 as because n minus 1 is 2 or more, okay, bigger than 1, right? And this is 1 row n minus 1. That's the key. So we have to assume that n is 3 or more. When n is equal to 2 or 1, we have to prove that separately, and it should be very easy. Okay, so we'll do it. I promise you. I give you my word. All right. So if 1 is can be expressed as 1 row n minus 1 because n is 3 or more, n minus 1 is 2 or more, so that's 1, right? So by what? Row reduction theorem, okay? So if you do that, then we can factor this out, all right? And this whole thing becomes, let's delimit this, okay? By row factoring theorem, uh, extraction theorem, and also row reduction theorem, okay? Okay, we are extracting row n minus 1, okay? 1 is 1 row n minus 1, okay? So you have n minus 1, row n minus 1 here, row n minus 1 here. The rest you add them, okay? So c plus n minus 2 plus 1, which is c plus n minus 1. C plus n minus 2 plus 1. C plus n minus 1, okay? So, okay? That's right hand side. Now, Next step, we're doing our very best to fit this into one page. We may not be able to, that's fine, but we'll do our best. Okay, so. We'll try. That's all we can do, okay? So, okay, let's spell it out, okay? So, NQ plus R, that's C, right? Okay. We want to get rid of this Q guy, okay? So, by row periodicity theorem, if you remember, okay? Row periodicity theorem. Row algebra has its own periodicity, right? Just like Euclidean algebra, okay? So, we can multiply Q here and subtract, okay? So, NQ, because we're not get rid of Q, okay? So, Q times n and minus 1 times Q, okay? So, and then subtract it. NQ, it disappears, right? Okay. N minus 1 times Q, okay? We are subtracting that from this guy. NQ plus R plus N minus 1. Okay, that's the row periodicity theorem, right? What do we have left? NQ, they cancel out. Then we have plus Q plus R minus plus R plus N R plus N minus 1 plus Q. That's what we have left after this row periodicity theorem. Okay, so okay. Now we're gonna apply row periodicity theorem again. Row periodicity theorem. Okay, yeah, you can just subtract that, and that becomes R plus Q row n minus 1 E n minus 1 plus 1. Ladies and gentlemen, we got it. We are home, finally. The same as the left hand side. QED. Okay? We got it. Congratulations. Okay, so. Well, not yet. Well, not quite yet. Okay, so we have to do one more step. We need one more step. I'm sorry. we're running really out of space, but this guy is equal to what? Let me see. We are not quite there yet. Not just yet, okay? We have one or two more steps, okay? So let me see. I don't want to cheat. I don't want to lie to you. I'm not acting, okay? I'm a little bit confused, okay? Right aside. Okay. There's plus one, right? Let's rewrite this, okay? Because we need to preserve space, right? So row periodicity theorem, right? Okay, we have to make this compact because we really want to fit this in one page so that you can take a screenshot so that I don't have to switch out the board. Okay, so row periodicity theorem, okay, subtract that, you have what, r plus q row m minus 1 e m minus 1 and plus 1, okay, then what? Okay, after that we apply Euclidean reduction theorem, okay, Euclidean reduction theorem, all right. So n minus 1 e the left hand guy row right hand guy is like row m minus 1 row m minus 1, well, by contraction theorem. So we have contraction theorem and also uh, reduction theorem, right? This is equal to r plus q row m minus 1 row m minus 1 by contraction theorem, okay, so it becomes the same thing, and we have plus 2, okay. And that's the same as the left hand side right there that we did in the previous episode, okay. So we got it, okay. So this is QED, okay. took long time, but we made it. All right. Tomorrow we'll go over this again. I will switch out the boards and I'll show it to you. Okay, so but we got it. Okay. Congratulations. All right. Our next step would be the diagonal periodicity theorem, but they'll be a lot easier because we have a lot of foundation groundwork. Okay, so now I need to sleep, eat. Tomorrow I get back to work. Okay, so thank you. Good night. Bye. God bless you.